Hello, welcome to Undergraduate Tutorials, a special program that is designed for undergraduates, especially those that are studying science-related courses. Today on Undergraduate Tutorial, we are going to look at Physics 101, and the topic we want to consider is dimensional analysis. Now, it may not be the same course code in your higher institution of learning, maybe in your university or polytechnic, but just make sure that the course contents are the same so that you can follow us properly. Alright, let's begin without taking much of your time. Now, dimensional analysis is not a new concept to us, because back in secondary school you looked at the concept of measurement, where you considered quantities, dimensions and units. You looked at quantities, you looked at dimensions, and you also considered units. These are the three major things that we consider under dimensional analysis. And back then you looked at the fundamental quantities and the derived quantities. We were able to establish back then in the at the secondary school that fundamental quantities are quantities that do not depend on other quantities for their dimension, while derived quantities, they depend directly or indirectly on the fundamental quantities for their dimension. And we know the 7 fundamental quantities, the common fundamental quantities, talking about the mass, the length, then time, then temperature, then electric current, and then amount of substance, and then luminous intensity. These are the 7 fundamental quantities. The 7 fundamental quantities, and we know their dimensions. The dimension of mass is m, length is l, time is t, temperature is theta, electric current is I, amount is m, and this is phi. We use this. So these are their dimensions. And using these dimensions of the fundamental quantities, we can now obtain the dimensions of the derived quantities. Then we say that units are used to distinguish between 2 or more quantities. For example, if I write 50, and I write another 50, and I write another 50, we may not know the difference between these 50s until I start inserting units. So this is 50 kilograms, talking about mass, 50 meters, talking about distance, that's length, then 50 seconds, talking about time. So once units are placed on numerical quantities, we'll be able to distinguish the quantities and know what they represent. We know the quantity they represent. So we use units to distinguish between 2 or more quantities. Now, what are we expected to do in dimensional analysis, or what exactly is dimensional analysis? So let's define dimensional analysis, having did a recap of what you have done previously. So dimensional analysis is the study of the relationship between physical quantities based on their dimensions and units. So when we are trying to establish relationship between physical quantities in terms of their dimensions and units, we are carrying out what we call dimensional analysis. This dimensional analysis, we have higher aspect of it. Those that are studying engineering will still look at higher aspect of dimensional analysis when they treat fluid mechanics and maybe in thermodynamics also, or mainly in fluid mechanics or transport phenomena. They will look at other methods of handling dimensional analysis, like the Rayleigh method and Buckingham method. But in this study, we are going to focus our attention on the physics aspect. So the study of the relationship between physical quantities based on their units and dimensions. That's what we mean by dimensional analysis. And what are we expected to consider as far as dimensional analysis is concerned? So we are going to consider the following. We shall consider the following. In dimensional analysis. Dimensional analysis. 1. Obtaining the dimensions and units of quantities, of derived quantities, specifically derived quantities. 2. Finding constants that make a dimension correct. Then 3. Obtaining mathematical relationship between quantities. And then the last one, be able to finding the dimensions of quantities in equations. So these are the 4 things we are going to consider as far as dimensional analysis is concerned. So we'll look at how can we obtaining the dimensions and units of derived quantities, then finding constants that make a dimension correct, then obtaining mathematical relationship between quantities, and finally finding the dimensions of quantities in equations. So when we have a formula, we can actually find the dimensions of quantities in that formula, or maybe an equation, as the case may be. All right, let's begin with the first one, obtaining the dimensions and units of derived quantities. Obtaining the dimensions and units of derived quantities. So when we have a derived quantity, how can we obtain the dimension of a derived quantity and the units of a derived quantity? We are going to write out some steps to follow in order to do that. So to obtain the dimension and units of derived quantities, we take these steps. 1, take note of the quantity. And write the formula for calculating the quantity. That's the first thing we do. We take note of the quantity and write the formula for calculating the quantity. Then ensure that the quantity is the subject of formula. Ensure that the quantity is the subject of formula. Then 3, express all the quantities. Express all the quantities in terms dimensions of the fundamental quantities. Simplify to obtain the dimension. Simplify to obtain the dimension and replace the dimensions with appropriate units to obtain the units. Alright, just 4 steps that we have to take in order to obtain the dimension of derived quantities. So we are going to use these 4 steps to cite 1 or 2 examples before we go on a break. So we are still on dimensional analysis. Let's take first example. Okay. So example 1. Given that pressure P is given by P equals rho GH, where rho is density, G is acceleration due to gravity, and h is height. Find the dimension. Find the dimension of pressure. All right. Okay. So we are given the formula for finding pressure. You know, that's not the only formula that we can use to obtain pressure. We know that we have pressure due to height. That's the formula. If we are dealing with pressure due to height, we know that pressure also is force per unit area. But no matter the formula you use, you will still arrive at the same word dimension. So let's go with this. If we are following our steps, take note of the quantity and write the formula for calculating the word quantity. So pressure, the formula here given to us is rho GH, density times acceleration due to gravity times height. Okay, that's it. They say ensure that the quantity is the word, is the subject of formula in that expression. Here, pressure is the subject of formula. So step 1 and 2 covered. Then express all the quantities in terms of the dimensions of the fundamental quantities. So we have to write density in terms of the dimensions of the fundamental quantity. Density is mass over volume, and volume is length cubed. You see, that's why what you studied in your secondary school is important. We have a video on dimensional analysis for physics at secondary school level that we can make available for you if maybe you did not understand the preliminaries. So we can make reference to that video. We'll also leave a link to that video so that you watch it and master how to obtain the dimensional analysis of these quantities, these physical quantities. So density is mass over volume, and the dimension of mass is L, the dimension of volume is length raised to power 3. Dimension of acceleration due to gravity is length per time square, and dimension of height is also length, because we say that height, depth, diameter, radius, distance, displacement, wavelength, amplitude, thickness, they are all the same as what? Length. So they share the same dimension as length. So we have this. Now by the time we divide, we have length raised to power 3, and this is length raised to power 2. When these two lengths we divide this, we'll be left with length here So I will be having okay, let's just split it so that people can, nobody will complain. That's what this means. Times length over time square times length. So by the time we have this length over time square times length. So length and length can go, length and length can go. I will be left with mass only on the numerator, all upon length times this length times time square, which we can write as mass per length times square, or mass per length per time square. When you apply the mathematical law of indices, you have that. So this is the dimension. This is the dimension of pressure. That's the dimension of pressure. If maybe we want the units now, all we need to do, like we said here, simplify to obtain the dimension and replace the dimensions with appropriate unit to obtain the unit. Now, if we simplify here, that's what we have done to obtain the dimension, then we can decide to replace the dimensions with the appropriate unit in order to obtain the unit of the quantity. For example, mass is kilogram, length is meter, and time is what? Second square. So it means that the unit of pressure is kilogram per meter second square. That's the unit of pressure. And we know that the SI unit is Pascal. It's Pascal. There are other alternative units to this, like Newton per meter square, and so on and so forth. So if we are required to obtain the unit, the question says just the dimension of pressure. If we are required to obtain the unit, it means we are going to get to this point. Alright, that's all for now. We still have so many examples to solve as far as dimensional analysis is concerned. So we have looked at example 1, and we are going to look at example 2 when we return from this break. Make sure that you follow us constantly, because there is need for you to understand every part of dimensional analysis. We shall be back, and when we come back, we are going to focus our attention on more examples as far as dimensional analysis is concerned, and we are still looking at obtaining the dimensions and units of derived quantity. So we are still going to look at other calculations on how to obtain the units and dimension of derived quantities. Don't go too far. Thank you, and God bless you.